Well, hello everyone, and welcome to our webinar here, coming to you from Bellevue, Washington, just down the street from Microsoft and across the lake from Seattle. My name is John Brown. I'm a technical product manager here at Mobilize.net, and today what we're going to do is cover some new ground, show you some new tools. We're going to specifically talk about moving your Windows applications off the desktop into the new mobile environment. So specifically, how to transform that source code into something that can run on a browser as a modern architected web application. Here's our agenda. What I want to cover today is to tell you a little bit about ourselves first, and then show you some a brief discussion of some of the technical challenges moving a Windows app to a web app, some different approaches that you can take with addressing your legacy applications and what to do with them as they age. We'll do a demo of some new technology that's available today for you to use and try out, and then we'll open it up to a Q&A. Just a little bit of housekeeping now. We don't have an ability for people to verbally ask questions, but we have a place on the GoToWebinar dashboard that you can type in a question. We have some of our great engineering team on the webinar with us, and they can answer questions in real time, as well as put some of the more interesting questions up that we'll discuss after the demo's over with. So let's get started. Who is Mobilize.net? We are a company that's been around for a couple of decades. We've been really focused on the transformation of source code from one platform to another, not through syntactic translation, but really through semantic translation. So trying to understand via automation the intent of a programming pattern and recreate that with a new language on a new platform and often a new paradigm. Obviously, it's a difficult problem. We have a lot of cutting-edge artificial intelligence researchers on our team. We've been doing this for a long time. Many of you on this webinar may have used one of our products as a part of Visual Studio for years. When you opened up a Visual Basic 6 application in Visual Studio, it would ask you if you wanted to migrate it to .NET. And the tooling that did that was something that we built for Microsoft. We still sell that today as the Visual Basic Upgrade Companion, and I'll be showing you a very brief demo of that today. Our tools have been used by us for our customers and also by our customers themselves all over the world to migrate literally millions of lines of code from things like Visual Basic to more modern platforms like .NET, and they're available for you today. We're going to show you something new today, which is to be able to take .NET source code and actually create a new application with an HTML client side and a ASP.NET MVC backend. So looking forward to that. What are the challenges in moving yet Windows application to the web? Well, here's a few of them. For one thing, Windows has a great authentication model that's built in. You have both the user model in Windows with password as well as tight integration with Active Directory. So it's very easy to have a secure user authentication model when you build a Windows app. You have a private local file system on every Windows app that's available to it, both local machine as well as the network resources, and it's easy to read and write files from that file system. In your application, when it's running on a Windows machine, it's running in a private process memory space, and you know that objects that you create in that space are going to be protected and are going to exist until you explicitly destroy them. So that's something you don't even have to think about anymore with .NET. You know, memory management is a great part of that particular framework. You have, of course, the Windows registry where you can store information that's unique to a particular application user. You can store things like a list of the most recent files that were open. You can store the placement and structure of windows in the application that the user has created as a workspace, things like that. You have, of course, a very rich user interface and user experience available to you in .NET, where you have not only a rich set of controls that you can put on forms, but you have a great deal of styling properties that are available. And then, of course, all that sits on top of Windows, which has its own rich user experience for things like accessibility and stuff like that. And then finally, a Windows app has direct access to all the hardware that's part of the device via of course, the API and the device drivers. But .NET abstracts all of that, makes it easy to get at it. Your application may always assume or require that the user has a specific piece of hardware that's available for the application to communicate with. And then when you take that app and you look at what it's going to do when it's sitting on a browser, basically you don't have any of those things. You don't have a private local file system. You don't have a private protected process memory that you know is going to exist from one moment to the next. You don't necessarily have a very rich user set of controls to build a user experience, although certainly that's changing over time and getting better all the time. And you don't have access to a lot of hardware. You know, it depends on what's available on the device, but again, you know, the browser can be running on a variety of different devices. That device might have a printer attached to it, or it might have an accelerometer attached to it. So it's a little more indeterminate. When you migrate your application to the web, there's some things that you need to consider. For example, things like local storage and hardware access could probably have to be redesigned around. Certainly, access to the registry has to be designed around because it doesn't exist anymore on a browser-based app. It might be running on iOS or on Android, so there is no registry. Some things will have to be replaced. So you might have a custom control that does something interesting on a Windows form and have to build something from scratch or find a completely different paradigm for your browser-based application because there's no corollary for that control that you can just instantiate in the web. You have to think about the fact that you'll have multiple users typically accessing the same application process that's serving those web pages up as opposed to just a single one. So whereas on a Windows machine you've got one user, one process, and those are sort of together, on a web server typically you've got the web server running the server backend processes, and multiple users can be accessing that. So you have to think about how you manage sessions and how you manage state among those sessions. And of course you have to plan on scalability because you may not be able to support all simultaneous users with a single server. You may want to take your web application and serve it from a public cloud like Azure or Amazon Web Services. And so now you need to be able to plan for the elasticity that comes with that, which is being able to spread that web server across multiple physical servers running in the cloud, maybe geographically closer to your customers for performance. How will you handle managing the information and load balancing, not so much the operational side, but the architectural side? Okay, so those are some things to think about. You've got legacy applications. Everybody has legacy applications. Some of those applications are in great shape, some of them aren't. How to sort of figure out what sort of outcomes you should plan for them? Well, here's a way to do it that we like to talk about. Building a two-axis matrix. One axis is how important the application is to the business, how much unique IP it has, how much competitive advantage the code in that application offers, how functionally interesting it is to the business. And another axis is the sort of technical quality from low, where maybe it's buggy, it's out of date, it's on a platform that's no longer supported, it's written in a language where it's harder and harder to find developers because that language isn't taught anymore in school, has high technical quality, it's not buggy, it's on a modern framework, the architecture is a modern in-tier architecture, maybe with services layers and so forth. So if we were to take all your applications and sprinkle them across this matrix, they'd, and then look at the quadrants they fall into, let's sort of walk through what that tells us. High and up to the right, you have the applications that are super important, but they're also in very good shape technically. So these are applications that you want to invest in. They're probably the more recent applications that you've created, and these are the ones that you want to add features to, you want to continue to fix bugs, you want to basically keep them current. The next category are the applications that are in great shape technically, but they really don't offer a lot of unique value to the business. These are applications that basically let them run, but they don't make sense to invest a lot of money in if they're not offering any competitive advantage. The applications that don't offer competitive advantage and aren't very good technical quality are great candidates for being replaced with something you can buy off the shelf, such as Salesforce or Dynamics or SAP or some other collection of products. Maybe just use Microsoft Office, and Excel macros to do whatever this thing's doing. They're probably not worth investing in or replacing. So, again, off-the-shelf software. And now we come to perhaps the most interesting quadrant, which is very important to the business but low technical quality. So let's break those applications that fit into this quadrant into further subsecting of 3 different categories. The first category are the applications that are important to the business, but they are functionally no longer useful. The algorithms are perhaps not matching the current needs of the business. The workflows are not matching the current processes of the business. They lack the features that you'd really like to have. And again, the technical quality is low. These are applications that are good candidates for a greenfield rewrite. So, a classic model here where you can marshal your team, you can bring your users on board, you can really design what you think you actually need, and you can start rolling it out and building it, and delivering functionality that actually works for people. You have those applications that are critical to the business, but gosh, they crash a lot, they're full of bugs, they just don't seem to be very stable. These are applications that maybe are a clue that there's some process issues going on inside the development organization. Maybe the way that you do QA, quality assurance, needs to be reviewed. Maybe the way you deploy to operations and check to make sure that it's been deployed correctly needs to be reviewed. Maybe you need to think about your development processes and how you're doing Agile or Waterfall or whatever you're doing, and see if you can find a better way to prevent the future releases of this from being full of bugs. And then finally, there's the ones that I'm particularly interested in that we want to talk about today. These are applications that offer significant competitive advantage to the company. They have code in them with business logic that's basically represents well thought out and debug business logic that offers competitive advantage to the business. But it's on an obsolete language, it's on an obsolete platform, the architecture is not particularly modern, maybe it's very tightly coupled to the presentation, so it's not a particularly portable application. These are ones that lend themselves to being migrated to a modern platform, a modern language using automation, because that way you're going to preserve the quality and the integrity of the source code in the business logic, and not introduce the kind of bugs that you would if you're writing it from scratch or if you're going in there and making significant modifications. So that's what we're really going to show you today, is how you can use automation to do this kind of modernization task. The application that we're most interested in talking to you about today really allows you to take something that is as ancient as Visual Basic 6 and through 1 or 2 steps move it all the way to a modern web application. So instead of having code that is tied to a desktop, you have code that basically is portable because it'll run on any modern browser that supports HTML5. You can start with Visual Basic 6, you can start with C#.net, and both of those can take you to a web application. So the way that we approach this problem is by using some tooling that will take .NET, and if you're starting with VB6, the first thing we'll do is we'll take it to .NET, but we're not going to spend a lot of time there because we're going to use that simply as an intermediate jumping off point to get to the web. So from that .NET application, we're going to take basically all of the WinForms UI stuff and we're going to recreate it as HTML with JavaScript and CSS. We're going to then take the back-end code that's not UI focused and we're going to transform it from sort of the classic client-server .NET approach to a ASP.NET application that's running as a single-page application using the model view controller 4 pattern. So all the business logic, the business rules, the database access, all those things can largely remain exactly the way that they were, except obviously we're going to refactor them into this MVC pattern. So there's going to be some decoration of the code. It's going to be broken up into perhaps different files than you're used to seeing it, but there's going to be a lot of value out of that. And the good news is that we won't break anything, and you'll be able to read it. Let's do a demo and show you exactly how this works. So, here is something right out of the past. It's Visual Basic 6 running on Windows 8.1 machine. And of course, what we've got classically is forms with things like tool strips and data-bound controls and record selectors down here. We've got typical VB code. Here's some comments that look like some code that was commented out. We've got some comments down here, some things to do. You know, this is pretty typical stuff. Let me show you what this application looks like. Now, this is a demo application that we created internally here, primarily as sample code. And you can play with this exact same application on our demo section that I'll show you here in a little bit. What this represents is a fictitious application for a fictitious seafood wholesale company for their salespeople to take orders over the phone so it understands things like customers, inventory, products, orders, invoices, and stuff like that. It has, as I said, a lot of data-bound controls, so we're scrolling through the database right now. This particular application is using an Access database, MDB type file. It's local to the machine, and we will preserve that all the way through. Well, a lot of people have this kind of code still, even though VB is out of support. But if they wanted to get it off of there, we have a tool, and we've had a tool for a long time, the Visual Basic Upgrade Companion. I'm going to show you here very briefly. And what this tool will do is it will take in a VB project, even a VB group, and it will emit a well-formed .NET, C# or VB.NET language program that uses WinForms instead of the VB Forms package, and it's sitting on top of .NET 4. So all we have to do really is point to our VB solution, which I've already done. The system is going to go out and check to find all of the components that are used by that VB application. In this case, there's a lot of the standard OCXs like ADO and Common Dialog and stuff like that. So it says, okay, I can find everything, even if they're third-party custom controls, non-Microsoft controls. It needs to be able to find them, and it'll understand them. So then we can select some options here, and those of you that have used VBUC over the years, this will be very familiar to you, but the green check marks over here are the components that we're actually using. This lets us go through and decide how we want to migrate these. It understands most of the Microsoft standard controls. It understands some third-party controls like Sheridan. It lets us set some options for how we're going to actually convert the code. For example, here's a classic one where we're going to take on-error goto and we're going to convert it to try-catch. In this particular case, the output that I want is C#, not VB.NET, because our web conversion tool right now only parses C# as a front end. So when I'm through with this, I want to select Web Map as my option. I want to confirm my options, and then all I have to do is click on the upgrade button, and it'll start the upgrade process. This takes a little while. It's fairly fast, but it's not fast enough that I want to do it in real time while I've got people on the phone here and on this webinar. So what I'd like to do is basically show you exactly what that looks like. We're going to get, sorry, that's VB. We're going to get code that basically has some upgrade helpers in it that we use to make it easy to move some of these VB objects over to, and VB syntactic paradigms over to C#, and we get our actual upgraded application. So if we were to open that up in Visual Studio, you see we've got a Visual Studio file here, which I already have. Here's our solution right here. So what you're going to see here is on the right in our Solution Explorer, we see all of our forms that we had in the VB application. Here's the same form that we were looking at, but now it's been migrated to C#. So we see all the comments that were there are still there. They've just been converted to C# comments. We have some comments that the tool injects itself. It basically says, look, the form load event has modified behavior now from Visual Basic. Here's a link to some documentation on how it's been changed. And we can see down here that a lot of the code is very readable. It looks pretty much exactly like VB, except now it's in C#. So if you were familiar with the original application of VB, you should be able to pick this up, and with a little understanding of C# syntax, a little understanding of the .NET framework and how it deals with, those kinds of properties and events that we're using in VB, you should be able to pick up this code and support it and maintain it and extend it, if that's what you want, if you want a desktop application. But suppose you don't. Well, first of all, let's make sure that it works. So let's build it and run it, and let's see what we get. Oh, well, gosh, it looks exactly like the other one. Yeah. So what we've tried to do is maintain the familiar look and feel of the original application, but built it on top of the WinForms, Forms package, and .NET, so that now you can roll this out to your customers. They probably won't even notice that it's been changed. All the data-bound controls still work. We're still accessing the same database file. Okay. Let's take this and do something interesting with it now. So what I want to do is sign in to our new portal that we have to let you actually start migrating these things from .NET to the web. So studio.mobilize.net is the URL. Once you get an account and log in, you'll see initially that you have the option to build a new solution. Once you've created solutions, you have a place to view them. And we have some demo solutions over here. And if we click on that, we'll see that one of them is Salmon King Seafood. So let's just show you the couple of demos here that you can start looking at right away. And it looks like just a little slow getting started here. There we go. So if you want, you can actually look at Salmon King Seafood, see the code. It's the same demo software that demo code that I'm showing you today. Let's go back to solutions and let's create from the home page a new solution. And what we're going to do is, this is really a three-step process. The first step is we run an analysis tool on your code and we create some metadata about what we find in that code. We don't actually take the code, but we take some information that we create about it, primarily occurrences of different properties, different methods, .NET classes, your own classes, how many lines of code. We take all of that metadata as XML and we upload it back to this secure portal that you're looking at here, and then we'll run an analysis on Azure of that and show you what the information looks like. So let's go ahead and get started. We're going to download this little assessment tool and fire it up. And this is using click once, so it basically runs, and when it's finished, it removes itself. It doesn't leave anything except the installer, which is very small, in your downloads folder. So I need to log in again. The reason I have to do that is because the XML data has to be associated with an account and a solution, and so it's going to decorate the data with my token so that the database knows whose solution this belongs to. So I need to point to a compiled, complete C#.NET application source tree. So I got to find a solution file here. So I go and I look locally, and here's the solution file that was created by the VBUC that we were just looking at in Visual Studio. So I just select that, say open. I can give it a name. We'll call it whatever we want, and then we say assess. So what it's going to do now is it's going to download the application. It's going to run the data collection model. It's going to build the XML files. It will store them in your solution. So if you want to see what the XML files are collecting, basically it's taking the every property, every method, every event that's in your source code, and it's documenting what those are and what the occurrence level of them are. And then it's going to upload the data and build the analysis. So we're going to see that here in just a second. once it's done, you will see it appear in the application, back in the create a new browser window, and you'll see all of your solutions that you build here. So you can always create new solutions, and you can also save, rerun the assessment tool and save it with the same name. So here's one that we just did. Let's take a look at that. So here's our application now after we've run the assessment and we're presenting some information about it. So in this particular case, what we're seeing is that of this application, this .NET application that started in VB, we are about 90% green. And by green, what we mean is that that source code, all those properties, those methods, those events, we call those PMEs for short, they should map right over to the web. In the new application, you shouldn't really have to touch any of that code. About 5% of this application is red, and you can see in the pie chart, and that's, by that we say it's really, this is not available on HTML5. Now in this particular application, in the original VB version, there was a help menu. The help menu brought up an about box, like a lot of help menus do, and in the about box was a button that said sysinfo. If you clicked on that, the VB code would go out and use some Windows API calls to get information from the registry about the amount of memory that was installed on the machine, the name of the machine, the version of the OS, typical stuff. That isn't available in HTML. So this is red. The code won't break anything, but it won't execute either. Okay. So we'll actually see that when we migrate this. But right now on the .NET side, it's all turned into sort of pinvoke stuff. And none of that will map to HTML. Now we also see that there's a little bit of yellow on this pie chart. So what does that mean exactly? The yellow is things that we found in your application, specific classes or properties or event handlers or methods that we may not be completely sure what they are. So it could be that we haven't yet created a mapping for it. It could be that we have a mapping in work, but it hasn't been published to the production environment yet. It may be that it's something that's unique to your application that we could create a mapping for if we took a look at it. So typically, if you see some yellow and you want to get a little more granularity on it, just call one of our engineers and they'll take a look at it with you, and they can give you some really fast feedback about what's in there and what your options are to dealing with it. So there's a lot of information here on your application. We see down here that we've got a number of lines of code, both design and logic code. We see what our projects are. We're going to see what our all the different classes, the number of methods that we have, and so forth. We can look over here and click on this and get a dependency analysis, which admittedly for this application is microscopically small because there's only 2 projects. We can look at each of the forms and see what the ratio is of logic code to design code. We can actually look and see a list of all the controls that are used by each of the forms, and we can see, if we want, what APIs are used by each of the forms, and what the curve on that is. By going all the way down to the bottom, you can see the ones that are the most common. So there's a lot of stuff here that you can have fun with when you're looking at your application. Once we've reviewed it, if we think that this is a good candidate for migration, we can click over here and click Migrate and actually start a migration. Now the first thing that we're going to have to do is a little configuration stuff. We really right now just have 2 choices when we create your new web application. The first choice is how we're going to handle fonts. So every object typically in your on your WinForm is going to have, if there's text on it, it has a font property. The font property includes things like size and weight and font name and so forth. Normally in a web application you have a fairly limited set of fonts compared to what's available on a clean desktop install of Windows. So you have a choice of either using a simple set of default fonts that would be very typical for a web page, like sans serif, 10 pixels or 14 pixels or something, in a site-wide CSS file. Or if you select true for generate fonts, what that means is every property that has a font declaration, even if it's a default font declaration, will get an explicit font declaration in a CSS file for that form. So you'll create a lot more CSS, you'll create a lot more CSS files, and you'll create a lot of font declarations. There's no guarantee that those fonts will actually be on the user's browser. Obviously, we have no idea knowing what fonts are going to be available to the user's browser. If you're concerned about the way fonts get positioned and sized on forms so that everything lines up correctly, you'll need to do some work here and possibly think about using something like Google Fonts or Web Fonts to get, to replace very exotic fonts that you're using in your application. In the code separation configuration button, basically we're going to give you the choice between optimizing the client side that we're going to build for size or speed. If you optimize for size, which is the default setting here, then we will try to minimize the amount of JavaScript that we create that has to be loaded and run on the browser side application. And we'll create, as a consequence of that, more server round trips for basically whatever kind of calculations or processing or authentication has to happen. If you select speed, we'll try to find those pieces of code, if you will, in behind your Windows Forms application to understand that don't need to access the server, so they're not data bound, for example. For if it's a simple calculation or a simple data validation, and we'll try to create JavaScript that can be executed on the client side without requiring a server round trip, so that you can have an application that's a little more performant to the user experience. Of course, what's typical is after you create your application, you do a certain amount of monitoring and profiling and testing, and you try to find the places where you might have some slowdowns or some speed ups that you could implement, and you move things around. So this is just to set the initial application before you do any profiling on it. Once we've done that, then the next thing that we have to do is we actually have to upload our files to the portal so that we can run the migration engine. So what I'm going to do here is I'm going to go back to this application that we have analyzed. I need to use the same one. I'm just going to select all the files, and I'm going to create a zip file of everything that's here, just like that. And then I'm simply going to drag it over to my panel here and just drop it. If that doesn't work, or if you have some reason that you want to do something different, if you click down here, we will send you via email some secure FTP credentials. Now we're running under HTTPS, as you can see, so the logjam hack aside, which was just announced the last day or so, this should be very secure because we're encrypting via HTTPS all the files before they get uploaded. So the next thing we're going to do is we're going to click Migrate, and what this is going to do is it will start the migration engine on a virtual machine in Azure, and then it will give us the output. Now this takes just a couple of minutes, but let's jump ahead to one that I've already done so that we can not have to sit here and wait. This one's going to go, but in the meantime, I'm going to go back to here and find one that I've already migrated. So after the migration, what you're going to see is the same readiness analysis, but you're going to see two more tabs here. One is compare, one is preview. Okay. So let's look at the compare tab. What we've done now is we've migrated your code, and we're showing you the old files that were the WinForm C#.NET version, and we're showing you all the new files, which is your new web app. Let's expand this by minimizing this column over here and just take a quick look. For each of these files, now we see that we have some new folders beyond what we had before. We have a bunch of new projects. We have scripts, we have some modules, we have all of our forms. But now notice that we have controllers, we have models, we have things that we never had before. So if we were to go in here, for example, and pick one of these, we'll see on the right it'll highlight the comparable forms. So if I pick one of these designer files, notice that it's going to highlight, I know the highlighting is a little dim here, it's going to highlight the HTML form. If I then go and look at this in both views, the file that I selected over here, it will show me file here that was original will show me the file that's most closely correlated to that one. In this case, the designer file gets replaced with an HTML file, so there really isn't a lot of before and after code to look at since none of that code is the same. But let's look at the same form, but look at the C# version. And now the selected form over here is our logic file. Okay, and by looking up here, and let's minimize this one, we now actually can see some of the changes from the C# file to the new file. And notice that one of the things that's pretty obvious, if I scroll over so you can see some of these, just a little bit more of each line of code, you'll see that, for example, here, where we had an explicit control called order ID, we're now actually dealing with a view model of the order ID. So we have broken this single tier or two-tier application, if you will, into a well-formed model view controller pattern. And we'll see a little bit more of that in detail in just a moment when we look at the application in Visual Studio. The other thing you can do in this mode here, before you do anything else, is you can actually see a quick preview of how these forms are going to migrate to HTML. So you can kind of get an idea of what they're going to look on. For example, here's one of the forms here, and what we're going to do is we're going to try to parse the HTML and represent it on the screen here, showing some of the controls that we understand. Where we have controls maybe that are custom controls that you've created or user controls, we'll try to identify their location and the real estate that they take and put a space on the screen, maybe with a red box around it, so you know this is something that we can't map, but we understand that it's going to have to get dealt with on the browser side as well. Now, if you like your application, you can download it. You do have to pay for it first, so there is an option to buy it. We're going to let you look at the sample code and download that and run it as well. We've got it actually, the application's up on a web server, so you can run them and see what they look like. The other thing you can do is if you're not happy with the way things came out, you can always go back and modify your source code, maybe clean up some of the things that are giving you trouble as an HTML representation, and then migrate it again. You have to run the assessment again, and then you migrate it again. And you can keep doing this until you get it the way that you like it. Now, what would this be like in Visual Studio? So let's open up the application. Let's suppose that I've downloaded it now and opened it up. And what we're going to see is that we have a much richer amount of source code here, a much richer representation of the application because we built it as a web app. So some of the things to look at are there are a lot of helper classes here. We do a lot of the heavy lifting to deal with the issues that come up to move to a web application via these helper classes. These are all in source code. There's no runtimes here. There's definitely, you can look at any of these that you want and see how we do things. Normally, you won't have to look at these. You'll be able to see that there are a lot of classes and methods that we've created that are using the helper classes, and so you can step into them when you're debugging and see what's going on. But for the most part, once you understand the pattern that we're creating, you won't need to deal with these. Down here, just to jump ahead, this SKS support project, again, this is the legacy of the sysinfo registry lookup, and there's a lot of pinvoke stuff here that was basically some API stuff. So APIs to read and write from the registry, those aren't available anymore. We are using NuGet to manage packages, and you can see whatever that we need to have here under NuGet, but there's not much interesting there. This, however, is our application. So now what we want to see is that we have a lot of different folders. Collapsing this one, we see that we have our logic files, or business logic, and our backend code is at the root here, and each form has its own C# file. And these are going to look a lot like the ones that we migrated to using the Visual Basic Upgrade Companion, except again, you're going to notice that you're using view models of all of these objects have been abstracted to a model, and then we're going to create a view that we can actually serialize and send to the client so that it can be represented over there. You're going to see that there are a lot of JavaScript and TypeScript files in here, we do require you to use TypeScript 1.4. We are using Kendo UI as a JavaScript framework on the client side, and that allows us to do two things. It gives us a very rich set of controls and widgets which resemble the Windows form controls and widgets. And the approach that we took with Kendo was because many of our customers have explicitly told us that when they migrate an app from Windows to the web, the initial look and feel they want is to be as similar to the Windows version as possible, so they don't have to retrain their users or their customers. Now, some of our customers are independent software publishers, and they want to have a SaaS model, software as a service, from a classic licensing model where they sold upgrades. And those customers a lot of times want to have a more modern look and feel. They want to have a responsive design so they know the application will behave well on different devices. And for those customers that are interested in that, we also are putting the finishing touches on a version of this product that doesn't use Kendo. It uses Angular, and it also uses Bootstrap so that the design will be responsive right out of the gate. So if that's something that you're interested in, we can certainly talk to you about when that's going to be available. We're getting just very close to finishing it up. If you're already standardized on something different, for example, Knockout, that would be something to talk to us about. We're largely agnostic about the framework that we use, but we do have to build to support it. So what else are you going to see in your new application code? You're going to see all of your forms now have a CSS file and an HTML file. So if we look at this customer form, here's our HTML, and we see that we've created, for example, IDs for every button, every text field, every label, all of these objects, and we've styled them with its own CSS file. Okay, so, or sorry, where's my CSS? Here it is here. So every one of these objects has the properties, the styling properties that were in Windows have now been translated into cascading style sheet elements. So we have that. We also have, for each one of our forms, we now have a model file. Okay, so if we look here, we'll see that here's the model for this particular form. So every object now has been declared as a view model of that particular object. So down here you can see the tool strips. Each one of the buttons on the tool strip has a view model or a model for that. Each one of the text boxes has it, and so forth. One of the things that we talked about earlier that you have to do when you migrate an app to the web is you have to be able to deal with multiple sessions. You really don't know that you're going to have persistence when a user does something. You don't really know. You definitely can't count on only having one user running against one process. So how to deal with that? The way that we approach it is we're using the Unity framework for inversion of control, and we create a context for every interaction. And the context basically is a session ID that identifies uniquely which browser and page on that browser, in other words, which unique instantiation of the application created a particular activity on the server side. So consider a form running in the single page app on the browser. The user fills out some information, makes some selections, and clicks submit or OK or whatever you have on your button. That information then gets modified into the model using the MVVM framework that's sitting on the client. It gets serialized as a JavaScript object notation and then sent, of course, via HTTP over to the server along with the session ID. The server then takes that information and translates it back into something that the logic file and the controller can use because it's removed the actual presentation of the data through these view models, and it deals with it, it updates the database, it does a lookup on the database, whatever it has to do. It rebuilds the information as a view and then serializes that model, sends it back to the client where then the MVVM framework takes it and turns it back into a presentation that the user sees. This all sounds very complicated, but it's your classic model view controller abstraction of the presentation from the logic, from the intermediaries that have to handle all those things. So that's what you're going to basically see over here in these files, plus a certain amount of stuff that's part of the ASP.NET pattern. Now remember, we're using a single page application, so the template itself has things like the index page and the about page, but typically those aren't used in an SPA. So they're here, but we're not doing anything with them. Of course, you can if you want. So let's see what this would look like if we ran it. And again, using the Kendo UI, the expectation is that it's going to resemble the Windows application's form look and feel as much as possible. So we're going to run this here just locally on localhost. We do require right now Visual Studio 2013. We will be supporting Visual Studio 2015 as soon as they finalize the bits. It should all work fine. As far as I know, this should work with Visual Studio 2012, but I can't swear to it. So here's our application. We have our menu across the top now. We've turned into a menu that understands that I'm hovering over it with the mouse. We can select these menu items, and we've recreated with little icons actual links here that work like the tool strip way back at Visual Basic time. We're still have data-bound controls. We have it's basically the look and feel of the original application, where we have, in effect, a frame inside the DOM, and we have this form that we've instantiated that looks a lot like an MDI application. So we basically recreated this application as a web application, but maintaining the ability to have it look like it was running on Windows. Okay, so if we were to look under the hood, what we would see as we get in here, and you can certainly look at this with the sample code, is exactly how we're going to serialize all the data, what's going on with the JavaScript that's on the client side. And you can take a look at that and sort of understand a little bit better what's going on as we handle these events and objects on the client side and then deal with them on the server side. The other thing that you get out of this is you get something that's really quite straightforward in deploying on a public cloud. So if you don't want to host this website from your own web servers, you don't want to have to deal with all of the hardware issues and the configuration issues and the monitoring and supporting issues, you can simply use the Web Publish Wizard in Visual Studio and put it up on Azure. I'm certain there must be something like that for other public clouds as well. We happen to have done this with Azure, but we have it up here right now running on an Azure web server, and you can certainly go and run this app from there if you want. It's sksdemo.azurewebsites.net. Certainly welcome to try it out. I think right now I'm on IE, yeah, Internet Explorer, and you can see that basically it's going to run the same way. So what we've done that's different here, although it all looks the same, is the database is now a SQL Express instance that's hosted on Azure, and the application is actually being hosted on Azure, and so there's actually nothing on my local machine except this instance of Internet Explorer, which is connected to the Internet and is now accessing the application running in the cloud. So the application was built to be cloud ready. We could all get on here, and I'm sure that Azure would very nicely handle whatever load we imposed on it by scaling elastically up and down and dealing with all those things. We've had some customers who have as many as 20 or 30,000 users simultaneously accessing this code, so we've had to make it very scalable on the server side. So it's designed right from the get-go to be able to run across multiple servers running at the same time, be able to share all the state and keep everything in sync. Because a Windows application a lot of times has a very rich user interface, we've seen some customer apps, some real-world customer apps that have very, very large forms, if you will, with very heavily populated with controls that are data-bound. Sometimes the controls are list boxes or drop-downs that get populated with very, very large numbers of records. And so if you imagine the problem of taking all that state and shipping it back and forth from the client to the server, doing something with it, and sending that state back to the client, you can begin to see very quickly that this could be a problem. So it can make the app run sluggishly. It can make the user experience less than ideal. This is certainly something that we took into account in the design of WebApp, and we've been able to optimize this by doing some migrations for large customers who have very large applications with these sorts of problems. So one of the things that we've approached here and built into design is what we call lightweight delta management. So if I were to come in here and add in a node, do some things here, and then say submit, what's going to actually get sent back to the server is the minimum amount of information that's changed rather than all the state information. And by the same token, the server itself is going to keep track of the information that it thinks has changed and is only going to send back a lightweight delta to the client. So we're going to try and keep the app as performant as possible so that the user experience is as good as possible. What I'm going to do real quick now is I'm going to jump back into our presentation here very quickly and just show you a few other things so that we can go forward. So I just want to recap exactly what did we demo there. So we started with a classic Visual Basic application that had an MDI interface. It had controls like tool strip and a record selector and data-bound controls. Used data access objects for the ability to connect to the Access database. Had a lot of different forms, a lot of different controls, very typical. We used the Visual Basic Upgrade Companion to load that Visual Basic project and migrate it to a WinForms version. We were able to migrate those VB OCXs up to .NET corollaries. We can certainly migrate a lot of third-party controls to .NET corollaries. And what we got out of that, of course, was a native version of this application running on .NET 4.0. We created a Visual Studio 2013 solution. This is all source code. There's no binaries here to make this happen. So, we have a lot of helper classes and source code that you can take a look at. In this particular case, we migrated it to C#. VB also supports migrating to Visual Basic.NET, if that's something you're interested in. However, in order to go forward from .NET to the web, right now we only support an input of C# and WinForms. So we're not able to support yet WPF user interface or be able to work natively with XAML yet, although it's certainly something that's on the roadmap for the future. The application that we created with WebApp is MVVM or MVC4, depending on which side of it you're looking at. We're using a lot of helper classes here, again in source code, to make the app performant, to manage the sessions, to manage state with the server, to manage, to make it cloud ready and ready to scale very quickly. And of course, when we're done, we have something that at the time looks like your Windows application. It'll run on any modern browser. We tested on all the popular browsers, the current version and the prior version. It's running as straight ahead HTML and JavaScript. There's no browser plugins required. There's nothing here that will break on anybody's browser or that you have to worry about whether or not it's going to be supported in the future. So very briefly before we go into Q&A, let me tell you about a couple of real-world cases here. We had the call center for Pizza Hut. So the way Pizza Hut works is if you get on the phone and call them and order a pie, that call uses a routing system with VoIP, voice over IP, to go to somebody that could be anywhere in the world, really, who has a piece of software where they can take your order and then it automatically gets delivered to the restaurant, the Pizza Hut shop that's closest to wherever the call originated from, for delivery or for pickup. So the company, Pizza Hut, uses software from National Systems, and they have thousands and thousands and thousands of these call center agents, many of whom work from home part-time, and had this VB app that required, a lot of configuration issues, and it was running out of support, and was very difficult to update by people, by the IT department, because the people that are using it weren't really all that technically savvy. So what we did was gave them WebMap. They were able to, we helped them to convert this VB app all the way to a SaaS version. So now the company can deliver it as a subscription model rather than the update and maintenance model that's so typical of old school. It was very easy to deploy new updates because they simply change the web application and the customers never have to worry about it. They wanted a user experience that was identical to the VB application because they said, look, we have so many users, we can't possibly retrain all of them. Okay, so we need something that we can roll out absolutely seamlessly, and customers can start using it right away. They needed a very high level of reliability, really five nines. The number of pizzas orders that happened on Super Bowl Sunday or on Halloween pushes up into five figures, the mid five figures, literally something on the order of 40 to 50,000 pizzas a day just from Pizza Hut. So they're dealing with very high transaction volumes, and they have to have a highly performant application. They can't get clogged up anywhere to make this thing work. So they were very happy with this. They had tried to take their application and rewrite it as a web app from scratch. It just hadn't gone very well. Anybody that's tried that knows this can be a daunting task. It can take a long time. It can really hold up your ability to stay competitive in the marketplace. So we were able to cut that time down and get them going right away. A similar customer was Hutchins Systems. They have a credit reporting application for car dealers, so the car dealers can check what credit products are available, loan products are available for customers while they're in the showroom, sell them that car right away. Their application, again, was VB. It was monolithic. They had many of the same deployment, training, configuration issues that National Systems had with a non-technical audience. They wanted to move to SaaS, to a subscription model, and so by converting the code from VB to HTML5 using WebMap, they were able to, again, avoid any kind of disruption or retraining requirement because the tab order, the forms, the structure of the application was faithful to the original application, although they chose to have a more modern look and feel. Okay, so got something that looks a little bit more modern for their customers than the VB one was. It definitely was allow them to create a SaaS model very quickly compared to trying to do this from scratch. So another success story. You can try this yourself. You can go to mobilize.net/register, get an account. That account will direct you to studio.mobilize.net so that you can browse our demos, you can run our demos, you can look at the code, you can upload your own applications and do a trial migration, see what that looks like. You can certainly run assessments on the code and see how ready it is to migrate to the web. So what we'd like to do at this point is we've had some questions while the session's been going on, and I'd like to just pause for a second, take a sip of water, and look at the questions, and then address some of them.
Third-party controls.
Okay, so one of our questions is around our licensing and pricing model. For both the VBUC and for WebMap, our pricing model is basically scales with the size of the problem. So the bigger and more complex your application is, the more the license costs. And what we can do for you is give you a specific quote by looking at the assessment information that gets created, counts the actual lines of code. It's able to isolate lines of code that are duplicates or redundant. It's able to take out out of its count comments and empty lines. And so just basically give us a list of what the effective lines of code are. And we can talk to you about what the price would be if you want to get a quote. We have a question about third-party controls. Certainly projects that have third-party controls may need some a little more hand-holding to move them across, but we work with those a lot. A number of third-party controls we've already dealt with, and we may have mappings for them either to .NET or to the web. So if you have those, don't let that be a stumbling block. Get in touch with us so that we can collaborate with you on analyzing your code in a little more depth and giving you some feedback on what it would take to get those to the web. The question is, do you have to license Kendo UI separately? Yes, you can try it out for now, but if you want to put the application into, if you want to deploy it and put it into production, you'll have to get a license from Kendo. I think it's about $900. You only need one license for the application, but we'll put you in touch with the Telerik people so you can get the right thing. And then we have one last requirement or question about what are the system requirements. You do have to have a WinForms C#.NET application before you can migrate it to the web. If you start with VB, you don't have to get it completely stable, but you do have to get it to compile. Okay, so you'll have to remove all the compilation errors. We don't really care much about runtime errors at this point. You do need Visual Studio 2012, and you'll need TypeScript 1.4 and .NET 4.5, I believe. Well, that's all the time that we have now. If you have more questions, by all means, you can send them to me at johnbro@mobilize.net. You can send them to, you can call us up and we'll get you in touch with our engineers. We'll be happy to sit with you in a screen sharing session and under NDA and look at your code and tell you the issues that we can identify out of the experience that we have doing this. Thanks again for coming. I hope everybody has a terrific day, and goodbye.